Good morning, ladies and gentlemen. Welcome to the video lesson for the extension of Chapter 3, Section 2, which is parallel lines and transversal rules. This particular video lesson is going to cover more difficult problem examples as well as the idea of an extraneous solution. So we start off with that vocabulary. An extraneous solution is an algebraic solution to an equation or an inequality which, when in the context of the problem, cannot possibly be true. Therefore, that is an algebraic solution which is ignored and not used to answer the question. Now, what are we talking about here with parallel lines and transversals? Well, in the picture on this screen, there are 8 angles. Each of these angles, to exist, must be greater than 0, must be positive, and it has to be less than 180 degrees, or else this picture just cannot exist. So if we were to come up with a solution that claimed that any of these angles were negative, 0, or more than 180 degrees, that would be an example of an extraneous solution. So we're going to go through 3 examples of this. These 3 examples are going to embed more difficult equations into our transversal problems. All of the examples in our first set of videos were linear equations. These are going to be quadratic equations, but in theory they could be even more difficult equations than that if your level of algebra was acceptable. So what we do when we look at a problem like this, it says find the value or values of x if the following conditions exist. And then it gives us expressions for the measures of angles 3 and 6 in terms of x. So what we do is we go over to the picture and we locate angles 3 and 6, and we say to ourselves, well, those are consecutive interior angles. So according to the consecutive interior angle theorem, if lines M and N are parallel, then angles 3 and 6 have to be supplementary angles, which means that the measure of angle 3 plus the measure of angle 6 has to add up to 180 degrees. So what we do is we plug in the expressions from the directions. So the measure of angle 3 gets replaced with x squared plus 3x, and the measure of angle 6 gets replaced with 5x. That gives us an equation that contains only x, and we can use algebra to solve that equation. Now this is a quadratic equation. We can simplify it slightly by combining these like terms, which would give us x squared plus 8x equals 180. Now when we solve a quadratic equation, there are technically 4 methods we could use to do that. We could solve that quadratic by graphing the related parabola and looking at its x-intercepts. That's not really a time-sensitive way of doing this, so we're not going to do that. We could use completing the square, but a lot of students are not familiar with that algorithm. We could use the quadratic formula, or we could factor. Now the fastest of these methods is the factoring method, but quadratic formula would work equally well. Either way, we need the equation to equal 0. So the first thing that we do is we move the 180 to the left side of the equation by subtracting 180 from each side. That gives us x squared plus 8x minus 180 equals 0. Now we could use the quadratic formula here, or we could factor this. Now quadratic formula would work, but 180 is a pretty big number. So honestly, we're less likely to make a mistake, assuming that we're comfortable with factoring, if we use the factoring method. Now the factoring method says that we need to find a pair of numbers that multiplies to negative 180 and adds to positive 8. Now these two numbers are going to be the numbers that go into our binomial factors, okay, along with our x, to generate our factors. Now what we're looking for here, if they multiply to negative 180, then one of the numbers will have to be negative, the other number will have to be positive. So really we're looking for 2 numbers that multiply to 180 and subtract to 8. Now that would be 18 and 10. And since the 8 is positive, the 18, the larger number, would be positive. If we multiply 18 times negative 10, we get 180. And if we add 18 and negative 10, we get positive 8. So those are the numbers that are going to go into our two binomials. We'll have x plus 18 and x minus 10. Now once we get to this point in our solving by factoring method, what we do next is we apply the zero factor theorem. We have two expressions here, x plus 18 and x minus 10, that are being multiplied together to equal 0. The only way that is possible is if one of those two expressions is 0, which means that we break this up into two separate equations. Either x plus 18 is equal to 0 or x minus 10 is equal to 0. We solve each of these expressions. They're both one-step equations and very easy to solve, which gives us two possible solutions under algebra. X equals negative 18 and x equals positive 10. Okay, so these are our two algebraic solutions. However, we cannot trust that these solutions will actually work in our transversal problem. So what we have to do is we have to check our answers. So let's say that we start by checking x equals negative 18. What we're going to do is we're going to plug that value in for both of our angles. So angle 3 is x squared, negative 18 squared, plus 3 times x, 3 times negative 18. So we feed that to our calculator. Negative 18 squared is 324. 3 times negative 18 is negative 54. So we go 324 minus 54, and we get that angle 3 is a 270-degree angle. Angle 6 is 5 times negative 18, or negative 90 degrees. Now there are two things wrong with that. Angle 3 is too big. An angle cannot be greater than 180 degrees in this picture. And angle 6 is negative, which is also not possible in this picture. So we would go to ourselves, oh, you know, those definitely aren't going to work. Now notice that algebraically they work fine. 270 plus negative 90 is 180, so that does satisfy the equation up here. That does satisfy that equation. But it doesn't work in the context of the problem, which means that x equals negative 18 is an extraneous solution, and we do not keep it. We throw it away. So then we need to check our other answer, and you do always need to check your answers. So x equals 10. The measure of angle 3 would be x squared plus 3 times x. That'd be 130 degrees. Angle 6 is 5 times x, or 50 degrees. Those are both perfectly acceptable. So that is our solution. Our answer is x equals 10. Okay, on to the next example. Okay, so here's our second example. Again, we see the same directions. Find the value or values of x if the following conditions exist. They give us an expression for angle 2 and an expression for angle 3. So we look at the picture and we say to ourselves, all right, well, those line segments are part of a bigger line, which means we do have a parallel lines and transversal situation. Angles 2 and 3 are once again consecutive interior angles, which means by the consecutive interior angle theorem, we know that angles 2 and 3 must be supplementary. So the consecutive interior angle theorem allows us to set up the equation that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Once we know what equation we're supposed to write, we plug in our x values, giving us x squared minus 26x minus 5x has to equal 180. We combine like terms, giving us x squared minus 31x equals 180. And then if we're going to solve by factoring, we need it to equal 0. So we subtract the 180 from each side. All of these steps are eerily similar to our last example. Now when we factor here, we're looking again, we've got a equals 1 factoring, so easy factoring. we need to find two numbers that multiply to negative 180 and add to negative 31. That would be negative 36 and positive 5. So, those are the numbers, negative 36 and positive 5, that are going to go into our binomial factors, giving us a factored form of x minus 36 times x plus 5 equals 0. Now again, the only way that that expression can be true is if one of those two factors is equal to 0. So we break it up into two separate linear equations, x minus 36 equals 0, or x plus 5 equals 0. And then we solve each of those equations. Again, these are one-step equations. They are very straightforward. So we end up with two possible answers, x equals 36 or x equals negative 5. Now again, this is one of those things where it's possible that our answers could not work, so we do have to check them. So we'd start with x equals 36, and we're going to plug that value into both the measure of angle 2 and the measure of angle 3 to see if they work. So that would be 36 squared minus 26 times 36. We're going to feed that to our calculator, and we're going to get 360 degrees. On the other angle, we're going to go negative 5 times 36, which would be negative 180 degrees. Now notice that those numbers do add to 180, so algebraically there's absolutely nothing wrong with that answer. However, in geometry, in this picture, angle 2 and angle 3 have to be positive, which makes angle 3 impossible, and they have to be less than 180 degrees, which makes angle 2 impossible. So x equals 36 does not work. It is extraneous, and we throw it away. Algebraically, it does work, but in this problem, in the context of this problem, it does not work. So then we check the other one, x equals negative 5. The measure of angle 2 is negative 5 squared minus 26 times negative 5. Okay, so we'd feed that to our calculator, and we would get that 25 plus 130, which would be 155 degrees. Angle 3 would be negative 5 times negative 5, or 25 degrees. These numbers are perfectly acceptable for this problem, so their answer is x equals negative 5. Now, the reason this example is in here is because we cannot assume that just because an x value is negative, it will not work in one of these problems. You have to check your answers. It is possible that x could be a negative. It's possible that x could be 0. It's possible that x could be some huge number. You just don't know until you check. You have to check your answers for x to make sure they create angles between 0 and 180. One more example. So here's our third and final example. Again, the picture is something we've probably seen in other problems. Find the value or values of x if the following conditions exist. Angle 2, which is here, is x squared plus 3x, and angle 6, which is here, is 5x plus 48. Now angle 2 and angle 6, we look at that picture and we say, oh, those are corresponding angles. So according to the corresponding angle postulate, we expect that those two angles will be congruent. Okay, the corresponding angle postulate says that angle 2 is congruent to angle 6. Now what that means is that the measure of angle 2 has to equal the measure of angle 6, because that is what congruent means, is that they are the same size, same shape. So if the angles are congruent, their measures have to be equal, otherwise they would not be the same shape. So we plug in our expressions. We have x squared plus 3x is equal to 5x plus 48. Again, we have here a quadratic equation. So if we're going to solve it by factoring or quadratic formula, we need everything to be on one side. So we're going to move the 5x and the 48 to the left side in order to make the equation equal to 0. So we will have x squared minus 2x minus 48 equals 0. which means we're looking for a pair of numbers that multiplies to negative 48 and adds to negative 2, which would be negative 8 and positive 6. So this will factor into x minus 8 and x plus 6. Again, these numbers go into your parentheses. Once we have that, that is a factored form, and one of those two factors, the only way that this expression can be true is if one of those two factors is equal to 0. So we break it up into two separate equations using the zero factor theorem, which says that either x minus 8 is 0 or x plus 6 is 0. And then we solve each of those expressions. So the first answer we would get is x equals 8. The second expression we would get is x equals negative 6. All right, so now we just need to check our answers. So we start with 8, and we plug it in. The measure of angle 2 would be 8 squared plus 3 times 8, which would be 64 plus 24, or 88 degrees. The measure of angle 6 would be 5 times 8 plus 48, which is 40 plus 48, or 88 degrees. 88 degrees is positive, and 88 degrees is less than 180, so x equals 8 is an acceptable answer. Now we need to check the other one, because it is possible that both answers could work. It's also possible that neither answer could work. This is why we have to check every single answer. So we check x equals negative 6. The measure of angle 2 would be negative 6 squared plus 3 times negative 6, which is 36 minus 18, or 18 degrees. The measure of angle 6 would be 5 times negative 6 plus 48, or 18 degrees. That answer is also fine, which means we're going to keep both answers this time. This problem has two answers, x equals 8 or x equals negative 6. Both answers work, so we keep both answers. Now again, it is possible when you have a quadratic equation, you're going to get two algebraic solutions. You have to check those algebraic solutions because it's possible that both answers work, that only one of the answers work. It is even possible that neither one of the answers work. That's why you have to check your answers. The second you don't, it will burn you. Thank you very much for your time and attention.